Today we're doing day 2 of 3.6, which is interval notation. And interval notation is important because you're going to be using it for the rest of the year to label or to write your answers for inequalities. But you're also going to be using it a lot in Algebra 2, and it's going to be how you write all your answers for your inequalities and also how you write your answers for your graphs. So there are 3 symbols that you need to know for interval notation. 2 of them we've already discussed, which are the parentheses and the brackets. So if you notice, the parentheses are the ones that we use when we have a greater than or a less than sign, no equal to. The bracket is the one that we use when we have a less than or equal to, a greater than or equal to sign. And infinity we're going to use to show where our endpoints are if that line keeps on going. So you're going to see what I mean now in these examples. If you look at the examples, you have x is greater than or equal to 2. So I'm going to put a bracket on the 2 because I know that it is a bracket since it's equal to. And it's greater than, so it's going to go this way, towards the positive infinity. Because if it goes this way, the numbers keep going on forever and they're going to be positive numbers. So my interval notation denotes my endpoints, where it starts and where it ends. Well, where does it start? It starts at the 2. So I show that by putting a 2 with a bracket because it's included. And it ends, well, it doesn't end. It keeps going. So therefore my other endpoint is infinity. And infinity is always with a parentheses because you can't pinpoint infinity. It's an infinite amount of numbers. So you put a parentheses. If you look at the next one, x is less than 2. The less than sign, there's no equal, so I know that it's going to be a parentheses. And it's less than, so it's going this way, towards the negative infinity. So my start and end points, so I'm always going to start from the left and then go to the right, is going to be negative infinity first with a parentheses, because infinity is always parentheses. And then the 2, because it ends at the 2, is second with a parentheses. The next inequality is an and inequality. And an and is going to have a start and an end because you're saying the x is in between 1 and 5. So you're starting at 1, parentheses, because it's not included, and you're ending at 5, bracket, because it is included. So you're saying, if you read it from the x is greater than 1, so you shade this way, and x is less than or equal to 5, so you shade this way. So it shows all the numbers in between 1 and 5, including 5, is what x can be. My interval is going to be my start point, 1 with a parentheses, and my end point, 5 with a bracket. The last example is an or. And ors are going to go in opposite directions. So you have 2 inequalities. One of them is x is less than negative 3. So it's a parentheses on the negative 3 going towards the negative infinity. So there's one of my intervals, negative infinity comma negative 3. And the second one is x is greater than or equal to 4, so it's a bracket. It's going towards the positive infinity. So my other interval is 4 with a bracket, comma, infinity, because it's going towards the infinity. Let's look at an and using intervals. So here you have in the interval, bracket negative 4 comma 6. This shows us that we have an and because we have a start and an end point. Unlike the ones that have infinity symbols, this is going to have a start and an end point. It's not going to keep going. So I know that on the negative 4 it has a bracket. Oops. Let's get our pen back. So on the negative 4 has a bracket, so therefore I know that it's included. And on the positive 6, it has a parentheses, so I know it is not included, parentheses, and it's shaded in between the negative 4 and the 6. If I want to write an inequality, I can do it 2 ways. I can either say x is greater than or equal to negative 4, because it is greater than, it also equal to, there's a bracket, and I have to put the word and, very important, so I know if it's an and or an or, it is less than 6. You can also write it all together with the x in between. So it would be negative 4 is less than or equal to x, which is less than 6. So you know it's between the negative 4 and the 6. Take a look at this example right here. Try to do it yourself. Make sure you pause the video. Okay, so here's the answer to that problem. Negative 2 with a parentheses, 7 with a bracket is shaded in between. x is greater than -2, and x is less than or equal to 7. And if you wanted to write it all as one inequality, you would put the x in the middle, you'd put the smaller number first, and then the greater number. It always goes in order from least to greatest. Ands are always less than signs, less than you can think of. And then since the bracket is on the 7, I have to put an equal to on the sign next to the 7. Okay, let's look at interval notation with or. Here you have x is less than or equal to 1 or x is greater than 2. So we're going to write it as an interval. Here is your graph. Since it is less than or equal to, you know it's a bracket and it's going towards the negative infinity. Here x is greater than 2, so it's a parentheses and it's going towards the positive infinity. So my interval is going to be negative infinity to 1, and the 1 is included. So negative infinity in a parentheses, -1 in a bracket, or, and very important that you write the word or, starts at 2, ends at infinity. 2 in a parentheses, comma, infinity. So look at the example on the bottom. What is a graph of y is greater than 7? How do you write y is greater than 7 in interval notation? And do it yourself. Take a second to try to answer that. That is not a compound inequality. It's just a regular inequality, so you only can have one interval. So here's your answer. It shows the graph of 7 with a parentheses going towards the positive infinity because it's greater than 7, and that's where the numbers get bigger. So your endpoints are starting at 7, ending never, but going towards the positive side. So 7 comma positive infinity. Both are in parentheses because there is no equal sign. This word problem says, to earn a B in your algebra course, you must achieve an unrounded test average between 84 and 86 inclusive. Now there's that word that I told you needed to know, inclusive, which means that you are talking about greater than or equal to, less than or equal to. And the other word was exclusive, which is less than or greater than. So you scored 86, 85, and 80 on the first 3 tests of the grading period. What possible scores can you earn on the 4th and final test to earn a B in the course? 4th and final, just so you know, means one test. It's the final test. It's also the 4th test. So the first thing we need to do is determine what is it that we are looking for. Let's do our let statement. So our let statement is going to be the 4th score. Then we need to come up with our equation. Since we know that we're looking for something in between two numbers, then we know that this is going to be an and. So it's going to be in between an 84 and an 86. And with ands, when we write them together, they're always less than signs. And since it's inclusive, I know it's also equal to. Okay, so now we know you scored 86, 85, and 80 on the first 3, and we're trying to find this average. To find an average, you add all the scores together and divide by however many there are. And we know that there are 4 scores, because one of the scores we don't know. We're trying to find the 4th score. So let's add them all together. 86 plus 85 plus 80 plus x divided by 4 will give me my average, and I want it to fall between 84 and 86. So before I split them up, I'm going to add the middle together, just make it a little bit easier. So it'll be 251 plus x over 4 is less than or equal to 86. I'm not going to divide by 4 because I can't just divide one number. I would have to divide x also, and so it's pointless to do that. So let's put into our 2 equations. We're going to have one that is 84 is less than or equal to 251 plus x over 4. Then we're going to have one that is 251 plus x over 4 less than or equal to 86. Then we solve. So the first thing I want to do is I want to multiply by 4 to get rid of the 4. That gives me 336 is less than or equal to 251 plus x. I'm going to do the same thing here. Times it by 4. Get rid of the 4. So I have 251 plus x is less than or equal to 344. Subtract 251. So x is greater than or equal to 85. Subtract 251 here. So x is less than or equal to 93. So that means that my answer, my test score, has to fall between 85 and 93, my fourth test score, in order to achieve that average. So I can write my answer in a sentence. I can write it all together as one inequality. And the way I would do that is I would make sure that I have the smaller number first, so the 85, the x in the middle, and the bigger number last, 93. They're both less than signs, and they're both equal to. And make sure it matches. X is greater than or equal to 85, x is greater than or equal to 85. X is less than or equal to 93, x is less than or equal to 93. So I know that my fourth and final score has to fall between an 85 and a 93 in order to obtain that average. Okay, I want you to read the next word problem and attempt it on your own. It's the same type of problem, and see if you can do it by yourself. Take a second, pause the video. Okay, so go ahead and look at the answer. My let statement is the value of the third reading. We set it up the same way we set up the last problem. Split them up into two, and you get your answer. If you write in interval notation, here's my answer in interval notation. Okay, which I don't really have to do.